I know how you feel about app architecture, and I feel the same. I always wonder if the choices I took while architecting an application will provide me the best outcomes in the future. But instead of worrying even for the tiniest details, I think we should take a real life example to understand this subject better. Let's imagine you got a great application idea that you strongly believe will be a great success. You want to start building it, and here comes the first roadblock, fueled by the question, which application architecture suits my app needs? Short answer, all of them. We all know that at some point the architecture we picked will somehow affect the fate of our project. Maybe our project will be very hard to scale, or we already burned all the capital for the project. Then let's make sure we took the best decisions right from the start. We will take the example of a simple social media app. For the moment, our application has only two simple features: authentication and user posts. Since our project is very small at the moment and we are unsure of its success, or we might have a very tight budget and short time span for development, we decide to implement a simple monolithic architecture, since it's very easy to implement and at first also the cheapest option. This means that all components of our software, such as UI, APIs, databases, will all operate as a big single unit. Everything is set up and in its place, so we deploy our application. Users start to download and use our mobile app. Requests pour in, and this makes us pretty happy. Now we live the life. We believe we achieve success. Until one day, Doomsday has come. A lot of users try to use our application at the same time. Too many requests are putting a lot of pressure on our infrastructure to the point it fails. Inside our monolith, because of its tight coupling nature, once something fails, everything will fail and our application becomes unusable. Our users are really unhappy and want to delete our app since it's not working anymore. But come on, we are smart. We fastly scale our infrastructure so our database can handle more requests. The order is restored. But one day our users request a new feature, a marketplace so they can sell their used products. We tell ourselves, no problem, let's add it inside our app. We redeploy our application with the new amazing marketplace feature, making our users pretty happy. Do you remember that we used a monolithic architecture for our small app, right? It seems like our application is not that small anymore, and the decision of still sticking with this architecture will haunt us in the future. You might ask yourself, but why? Well, think about the features of our app at the moment. We have a user posts feature and a marketplace feature, which somehow seem very unrelated to one another, but they still point to the same database and share the same infrastructure. This will be very counterproductive and pricey in the future when we will need to scale a feature more than the other. For example, our users will start to use a lot our marketplace feature and stop paying attention to the user posts. Because we use the monolithic architecture, when the need to scale up our marketplace feature will arise, we'll unfortunately be forced to also scale up our user post feature, which we don't necessarily want and actually we don't need at all. Once we come to this conclusion, we realize that we need a more flexible, cost-efficient, and easy scalable app architecture. Well, it's our lucky day. There's microservices architecture waiting for us to implement it inside our app. Now, let's get back to our example and switch it to a simple microservices architecture. I know, a lot has happened once we made a switch to microservices, but let's explain our changes. every feature of our app is broken down into its own self-contained block, the microservice, having the same functionalities as it did before, which will be called through API endpoints, and it also has its own private database. Our application is now modularized and loosely coupled, meaning that changes to one of our features will not affect the others, and every feature can now be separately deployed. Thinking about our previous example of adding a new feature, now, with the help of microservices architecture, we'll not have to worry about features not being related to one another and still sharing the same database and infrastructure. Adding a new feature will now be done by creating its own microservice with its own database and infrastructure, which helps us in the long run since features will be scaled up or down independently. Hence, our app will be more cost efficient. Failing? No problem. Now, if a microservice fails, our app will still run the same, and the microservices that are up will make sure that our application works as expected. Just that users will not be able to use the features of the failed microservice until we fix it. And one more thing before we go. Our microservices can also communicate between one another. For example, when a user creates an ad to sell his product, we might also want to create a user post based on the user ad. In this case, the marketplace microservice will communicate with our post microservice through either HTTP, a message broker, or gRCP. This choice is up to you, informing the post microservice to create a user post for the ad. Now our app architecture is looking neat. Still, there's a lot of room for improvements. We just scratched the tip of the iceberg. But now you have the power and insights to take better decisions when architecting your applications. I would like to point out that all the examples above are based on my experience and how I would implement a new application from scratch. No one will ever stop you from starting directly with microservices architecture or never switching to it. Since different projects have different funding and different needs, it will always be your call. Don't forget to leave your opinion in the comment section down below. I hope you enjoyed the video and see you soon guys. Peace.